Hello guys, how are you today? So today I'll be explaining the Math Online Quiz course practice of section 4.1 until, actually it's only 4.1. So the pure mathematics course practice of section 4.1. Without further ado, let's get started. So the radius of a sphere is increasing at a rate of 5 centimeters per second. So when you see increasing at a rate, this means it's something over dt. Radius means that it's dr. So dr over dt is what is 5 centimeters per second. When the radius is 3 centimeters, meaning that r is 3 centimeters, the rate at which the surface area of the sphere is increasing. So they want what? The rate at which the surface area. So rate means what? It means dt, and surface area, we'll say it's ds, is what we need to find. So very simply, how can we relate ds over dt to dr over dt? Very simply, look what happens. dr over dt, we need to relate it somehow to ds over dt. What happens? We keep dt the same. That means whatever we do, we cannot remove dt. But however, we need to add ds, and ds needs to be in the numerator. So we'll put ds in the numerator, and we need to get rid of dr. So that's why we'll put dr in the denominator. So that means we need to find what? We need to find ds over r over dr, which is the derivative of, I forgot how to write, my bad. Derivative of the surface area S. So of a sphere, what's the surface area? It's 4 pi r squared. So you take the derivative, which is 8 pi r. And now what do? You do dr over dt, which is 5, times ds over dr, which we found to be 8 pi r. And we know that r is how much? Is 3 centimeters. Is going to give us ds over dt. So that's going to be 5 times 8 times 3, which is 120 pi centimeters squared per second. We move on to question number 2. What does it say in question number 2? The volume V of a liquid in a container is given by the expression V equal 3h squared. So this is what? This is our volume, or we will say dV, where h is the depth of the liquid. They told us that the liquid is being poured into a container at a steady rate of this. So this is what? This is dV over dt, because the volume of liquid is increasing by 120 centimeters cubed per second. They told us when h is 5, they want the, right? So we have dV over dt, which is 120 centimeters cubed per second. Now they want us to find what? They want us to find the rate at which the depth of the liquid is increasing. So they want dH over dt. So how can we relate dV over dt to dH over dt? Very simply, we'll need to get rid of the dH. How do we do that? It's going to be dV over dH. So dV over dt is dH over dt times dV over dH. Or if you don't prefer using h and you prefer to use r, because most of the questions are like this with r, if you prefer to remember this equation and use it as r, it does not matter as long as you know and understand what you are doing, okay? So dr over dt is what? We need to find it. We have dV over dr because they gave us the volume. We just need to take the derivative of it, which is 6h. So you just substitute all of this by 6h. And they gave us h, which is what? Which is 5. Okay? And then dV over dt is how much? Is 120. So 120 is equal to dr over dt times 6 times 5. So that means dr over dt is equal to 120 over 30. So that's going to be 4 centimeters per second. We move on to question number 3. What does it say in question number 3? Okay, fill in the blank with the correct whole numbers. They want the estimate of the value of f2.02. So how do we do that? When they say they want the estimate of a value, you need to use the slope. How do we find the slope? Y minus y over x minus x. So y minus y, how do you find y? Basically, it's going to be, you substitute here. So basically, y can also be what? Fx. So when you're saying y of 2.02, it's the same as fx of 2.02 or f of 2.02. So that means y minus y, so f 2.02 minus f of 2 over x minus x, so 2.02 minus 2. What did they do now? They kept f 2.02, so we're going to keep that. But they did not keep f2. What do we need to do then in this scenario? We will need to substitute 2 in here, okay? So it's going to be 5 times 2 squared minus 2 times 2 plus 3. So that is That's gonna be 19. And then 2.02 minus 2 is 0.02. Now, let's make it in the format they want. They kept this, right? And they multiplied it by 1 over 0.02. That means that number over here is 19. Now, what about this number over here? Very simply, we know in order to find an approximate value of 2.02, what do we need to do? We need to take the slope, right? And how do we find the slope? In order for us to find the slope, we need to take the derivative of the equation, which is what? Which is 10x minus 2, and we will substitute a value that we are given. We don't substitute 2.02. Instead, we substitute the value 2. Why do we substitute the value 2 instead of x? Because we are not looking for the value of f2 the value of f2. We're looking for f2.02. So because we're looking for this, we cannot use it. That's why it's gonna be 10 times 2 minus 2, which is what? Which is 18. So it's approximately equal to 18. Now, if you want to check if your answer is correct, look what you can do. You will say f2.02 minus 19, all of it times 1 over 0.02 is approximately equal to 18. Now move this to the other side. You will get 18 times 0.02 is 0.36. So f2.02 minus 19 is approximately 0.36. Move 19 to the other side. So f2.02 is approximately 0.36 plus 19, which is 19.36. Now, if you want to check your answer, you can actually substitute 2.02 over there. So it's going to be 5 times 2.02 squared minus 2 times 2.02 plus 3, and you will get what? You will get approximately 19.36. This is how you check your answer. We move on to question number 4. What does it say in question number 4? A side of a cube is increasing. If you don't like to use any other substitute than dr over dt, then be free to use it, okay? It's increasing at a rate. That means dr over dt is 2 centimeter per second. When the length of a side is 5 centimeter, that means r is 5. The rate of increase of the surface area, so they want to find ds over dt is how much? So how do we find that? We know that ds over dt is equal to dr over dt times ds over dr. This is after many times of practice. You should have this memorized. We have dr over dt to be what? To be 2 centimeter per second. ds over dr is the derivative of the surface area. So what's the surface area of a cube? You should have this memorized. It's 6 side squared, okay? But because we used instead of s, we used r. So in this scenario, side is r. We won't say 6 side squared. We'll say 6r squared. Okay, so now you need to take the derivative of this. So it's going to be 12r. So you'll put it over here. Times 12r. And they gave us the value of r, which is 5. So you just need to put on the calculator 2 times 12 times 5. And you will get 120 centimeters squared per second. Okay, so 120 centimeters squared per second. We move on to question number 5. Same exact thing, but I'm going to try to do it in a different method without the r. We'll try with s. Okay, the side of a cube is increasing at a rate of this much. That means ds, because it's a side, over dt is 2 centimeter per second. The length of a side is 4 centimeters. What does this mean? This means s is 4. They want the increase of the volume, so they want dv over dt. What's the equation we know? We know that dv over dt is equal to ds over dt times dv over ds. How do we find? We have ds over dt first of all, which is 2. dv over ds is the volume of a cube, which is side to the power of 3. You take the derivative of it, which is 3 side squared. So you substitute this by 3 side squared. They gave us the value of the side to be 4. So it's 2 times 3 times 4 squared. So that's going to be what? That's going to be 96 centimeter cubed per second. We move on to question number 6. What does it say? Ooh, this question is very, very nice. The radius of a sphere increases from 5 centimeter to 5.04 centimeter. That means initially the radius is 5. And how much is the change in the radius? Or like the rate of change in the radius, it's 5.04 minus 5, which is 0.04. Now what do they want? They want the approximate change in the volume of the sphere. So they want dv over dt. dv over dt is equal to dr over dt times dv over dr. dv over dr is the derivative of the volume. Volume of a sphere is 4 pi r cubed, 4 over 3 pi r cubed. So you take the derivative, and it's gonna be what? It's gonna be 4 pi r squared. So we'll substitute dr over dt by 0.04. We'll substitute dv over dt by 4 pi r squared, but we know that r is 5, so 4 pi 5 squared. Now, using all of this, we'll be able to find what? We'll be able to find the change of velocity in time, or like the approximate change in volume, not velocity, my bad. I'm thinking about physics right now, my bad. So it will be 0.04 times 4 times 5 squared. So it's gonna be what? It's gonna be 4 pi centimeter cubed. We move on to question number 7. What does it say? Again, the radius of a sphere increases at this. So dr over dt is what? Is 10.05 minus 10, so that's 0.05 centimeters per second. Now, the radius is how much? Is 10 centimeters, and they want the change in surface area of the sphere. Surface area of a sphere is 4 pi r squared, so you take the derivative of it, or before that, actually, let's write the equation. They want ds over dt. So we know that ds over dt is dr over dt times ds over dr. ds over dr is the derivative of the surface area. So surface area is 4 pi r squared. You take the derivative. It's going to be 8 pi r. You substitute it here. 8 times pi times r, which is 10. And then dr over dt, we have it to be 0.05. So it's going to be 0.05 times 8 times 10. And that's going to be, again, 4 pi centimeter cubed. We move on to question number 8. The volume of a sphere increases at a constant rate of 3 centimeter cubed per second when the radius is 4 centimeters. Okay, first of all, let's write this. So dv over dt is how much? Is 3 centimeter cubed per second. Then the radius is 4. They want the rate of change of the radius, so they want dr over dt. What's the equation that relates these two? dv over dt is equal to dr over dt times dv over dr. What is the volume of a sphere? It's 4 over 3 pi r cubed. So you take now the derivative of it to find dv over dr, which is 4 pi r squared. So you substitute it here by 4 pi r squared. They told us that r is 4, so 4 pi 4 squared. And then dr over dt is how much it is. It's what we need to find, dr over dt. But however, dv over dt, we have it, which is what? Which is 3 centimeter cubed per second. So you move this to the other side. dr over dt equals 3 over 4 pi 4 squared. So after solving, it's gonna be what? It's gonna be 3 over 64 pi. So what's the value of k? The value of k is 64. Let's submit, and hopefully we don't have any mistakes. And perfect, thank God. Thank you guys for watching. I hope you enjoyed, and have a wonderful day.